So guys, real quick. In general, you could either reject the hoe, which means what would you say about the high? Support it. Or you fail to reject the hoe. Fail to support the high. You with me? That's the only things that could happen. That's it. Here we failed. You guys should be getting a z-score of about negative 1.62.
Yeah.
If you're not there yet, you know what to expect now.
So it's going to be this size.
Yeah, so let's do the whole thing. Let me catch up to you guys. So the claim was that the mean is less than 30 pounds? So that would be which one again? The high. So guys, everybody. So that'll be the high. That makes the hoe what? Greater than or equal to. Some books make this always equal to. It makes more sense to make it the opposite because my claim sometimes could be at least 30. So I have to have a greater than or equal to option. So how many tail tests? One tail. That tells me where it's going to be. Less than on that side. We can definitely use z-scores because as we eventually figured out, sigma's known. They didn't really word this one very well. But sigma's known, and n was 62, that's greater than 30, so I can use z-scores. Alpha in this case, I think, was 0.05 again. So we keep seeing this, but that's all right. It's down here. When you look it up, you see 1.645, but you know it's down there, so it's negative 1.645. We have to put the negative sign. So I know it's down there. Shade this in. There's my rejection region. So, this happens all the time in mathematics. It's really hard to remember how the idea ties into what the hell we do. I'm trying to say, they think it's right here. The 30 is right in the middle. So if I don't think it's 30, my sample has to be way down here. And that tells me how far down. Because if I get a sample that's right here, it is below, but it's like almost on it, so who cares? If I take a sample, will that sample have the same mean as the population in general? No. So to actually show evidence that it's lower or higher, it's got to be way lower or way higher to show evidence. It's just a poor little sample. You can only do so much. So it's got to be below this. So if my z-star is what? Less than negative 1.645, it'll be in there. Then we reject the hoe, support the high. Otherwise, we fail to those things. Oh, I think I got a little too zoomed in. Yes, ma'am. Ma'am? Yeah.
With the z-star, I would always go with the claim, like less,
Not the claim, but the high. You always go with the high. And you're right. Everyone we've done so far, the claim has been there. Because in general, normally the claim is, I think it's bigger, I think it's less. So most often that will be where it goes. We'll do one right now next where the claim is not going to be the high. But you're right. You can always do that. From the sample, we knew that n was 62. X bar was 12 something. Not 12, where? Oh, sigma's 12. X bar is 27. 443. Sigma was 458. Sigma X bar, who calculated that? What's the new standard deviation? 1.582?
Yeah.
So then Z would be our data minus the mean from this hypothesis. We always assume, we're going to say assuming that it is 30. So minus the 30 divided by the new standard deviation. And that's where you get the negative 1.62, roughly. So that's right here. Now, obviously, be real careful. I get people that get confused about negatives. Kind of, you got to be careful. So a few of you guys had it on the wrong side at first. But it's obviously not as negative as 1.645 negative. So it's got to be right here, maybe. So did we reject the null?
No.
So right here we can say fail. Guys, fail to reject or fail to support the high. How we doing so far?
Do we have to put both, or can we just put fail to reject?
You can just put this one, it's fine. I just wanted to be very explicit.
Okay.
Real quick, the p-value. Did anybody look up the p-value? Related to this?
Oh, yeah.
I didn't really ask you to, so that's all right. I just wanted to see. I didn't ask for it, but let's not do it. What's my conclusion now? Did we find evidence?
No.
No, we just said. We said we failed. So we have not found evidence. Which one of these? Was it the ho or the high, the claim? In this case, again, it was the high. So I want to use this wording right here. We have not found sufficient evidence to support the claim. That blah. He thought it was less than 30. He got 27 point whatever, but it wasn't less than enough. So you got to go, oh crap, I failed to find evidence for what I thought was true. We have failed. We have not found. Not found sufficient evidence to support the claim that the mean garbage weight less than 30 pounds. Okay, so we continue to get more and more excited about this prospect. I know. The more we do these, the more these become very standard things to do. This is the format never changes. It's just brand new to us still. So let's do another one. And actually, we're going to do one more. And I've got a handout for that, of course. But before we do it, it's from the section with the p-hats. So guys, everybody, who remembers the formula for the confidence interval for a p-hat? Just the top of your head. It's p-hat plus or minus. What's got to be here? There's got to be a z there, right? For everything. Anybody remember what goes here? And in this case, I want to make this point. Guys, why did these have to be p-hat and q-hat? What does that little hat tell me? So what would a p without a hat be from? Beautiful. We couldn't use without hats because in this case we don't know it, don't we? This is all about trying to find a confidence interval for what it is. We don't know, so we have to use the little hat dudes, right? This piece here, this is kind of cool. That piece there must be the what? Considering where it is. No, because when this whole thing is the error. Here, look at this. What was this? That is the standard deviation in this case, right? So what must this be? The standard deviation in this case. How are we doing so far? So that is the standard deviation when I'm dealing with this type of problem. When I'm taking P's and Q's and testing claims or making confidence intervals, that is my standard deviation. So my z-score for means, let's just write it like that. It's always our data minus the mean divided by the standard deviation. For p's, it's the same way. What did we just say? What's our data always going to be? What's the symbol for our percentage that we find from a sample? P hat. Minus, and what's the symbol for the population percentage? P, no hat. And what's going to go down here? This thing. But without hats. That's all. Why do I not need hats down here? Because I'm going to assume I know what the hell P is. Just like up here, we assumed we knew what mu was. Right? We just took it from the hypothesis statements. So here, we're going to know P. I don't have to use P hat and Q hat. I can just use P and Q. Maybe. So all the steps will be the same. I see you guys eyeing the clock. All the steps will be the same. It's just that when we get to step 4, we'll use this to calculate our z star. If you want to put a little star on there, that's my z star now. All right, so let me give you this. This will be the last thing we do. We're going to do it together. So if you want to ungroup up, that's a good idea.
Something we don't know how to do.
It's you, isn't it?
Feeling so lazy. Feeling lazy? Yeah. Or are you lazy? You have to do this. Seriously. Well, we've got 5 minutes, so we better do it together. Okay, let's take it for the series.
All right, guys. So this one's got a couple of new things. Obviously, it's going to be a percentage problem. We haven't done that yet. But it's also got something else that's kind of new. Reading through this, and obviously this was written a while back. I think they occupy Wall Street. They're not so much occupying anymore, but they're out there somewhere. Anybody just look through it. Don't even worry about all the numbers. But what's the claim that's being made? This one is that little
Are you
kid.
Mr. Waller?
Whoa.
Oh my gosh.
Hey, Sonny.
I'm interrupting class because your teacher just got an award.
You got an excitement for that?
And none of this really matters in life anyway.
It's the president of the college.
Hey, Sonny.
There's a certificate
No way.
for
What is
curriculum and your negotiation and mediation. And good job, Mr. Wall. Oh, look, he's going to take a video of us.
There we go.
Good job. All right, have fun. Study hard. Math is important.
It's interrupted.
Yeah, it's all right. Anytime you want to come and give me chocolate, you can come on in. Wow.
Let's leave.
That's random. You're a great teacher, Jeff. Just stop teaching right now.
Exactly.
All right, let's do this. That was so random. Hold on. All right. That was the president of the college, by the way, if you didn't know who that was.
Oh, really?
So when you see her come in the door, you pretty much say, it's fine. All right, so let's see if we can refocus. Anybody know what the claim is here? This one's, if it's not, I'll tell you this. If it's a one-tailed test, it's really easy. Because you're going to see words like greater, less, we think it's increased, we think it's decreased. So I'm kind of giving it away here how many tails. If it's a two-tailed test, it can be really tricky. I don't see any greater, less than. What is it that we feel? That's another word to look for.
Equal.
We feel that 20% of Americans, so the claim is that the percentage equals 20%. So the claim is P equals 0.20. So if you're not sure, if you can't tell what the hell's going on, it's probably a two-tailed test. If you don't have any explicit like greater or less.
So that's going to be two-tailed, right?
It's going to be a two-tailed test,
Two-tailed
exactly.
test.
So we know that's a two-tailed test. And that's another new thing here. Where does that statement go, the ho or the high? I'm so happy she didn't walk in when I was, the ho is in the high. You must reject the ho.
You can call it again if you want.
All right, so that's going to obviously be the ho, because the ho has got to have a
Equal sign.
I love it. So what's the high going to be in this case?
P it is now.
I love it. The opposite equal is not equal. So it's definitely a two-tailed test, because if it's not equal to, I can go down there or up there. You with me? So far, semi-decently? Okay. All right. Now, what other thing is going to change? What do I have to check on an NPQ problem to see if it's normal? It's not 30. It has nothing to do with 30 anymore. What do I check for an NPQ problem?
P and Q have to be
Though they always have to. Then may remember what you have to check before you can use like the NAB. This is not the NAB, by the way, don't freak out. What's the requirement for NPQ to be normal? NP has to be bigger than
Greater than
5,
five.
and Q has to be bigger than 5. So N here is 996. So NP would be 996 times 0.2. NQ would be 996 times 0.8. You guys with me? So what is that?
It's 199.2.
What? So this will be 796.8.
796.8, yes.
Hey, all right. No. I say whatever, Jeff. All right, those are both bigger than 5. Therefore, I can use these scores. I'll tell you this. It sounds like a note. You never have to use T-scores for an NPQ problem. Because either it's normal and you use Z-scores, or it's not normal and you don't do anything. With me? T-scores were not invented for an NPQ problem. They're invented for when I know the standard deviation or not. Now here, I always know the standard deviation because I make it. So I never have to use T-scores for an NPQ problem. Sweet. So what do I need to know to define the rejection region? True. How do I get the Z-score? What do I need to know to figure out the Z-score?
Use your T-chart.
I know it's a two-tailed test. What's alpha?
0.02.
0.02. I love it. So if you look up, and this is kind of cool. Again, here's this thing in action. Two-tailed test, 0.02. We're not using T-score, so you don't stop. You go all the way down. 2.326. You guys see that? That's why this thing is so awesome. I got a two-tailed test to go here. I got a one-tailed test to go there. Can't go wrong. So now I forgot what it was. 2.326. So it should be negative 2.326 and positive 2.326 because it's a two-tailed test, right? So the Z-star I find could either be in here or down there in order to do what? If Z-star is less than negative 2.326 or greater than 2.326, what can we do? Careful.
Support,
You never support the hoe.
support the high and reject that.
You with me? And that makes it easy to remember. I mean, obviously, if anybody's easily offended, I'm not sure what you're doing in my class, but it makes it easy to remember some of these things. You never support the hoe. You either reject the hoe or fail to reject the hoe. Well, we won't get into all that. So D is where we actually figure out, compared to that benchmark, where did we make it? Yes, ma'am.
What were your signs? I didn't see that. It's less than negative 2.326.
Good, and that would put it in there. And greater than 2.326 would put it in there.
Okay.
Cool. We try to power through this a little bit. N was 996. What was X? What is the number of successes in this case?
189?
Yeah, 189 people that said that, right? So P hat, of course, is going to be the part divided by the whole. So somebody help me out. What's that going to be?
0.1897.
So like 0.190 if you round it up. Is that cool? 1897, that'll round up to 190. 0.190. And I gave you the formula there. So now you just got to fill it in. What's P hat?
0.19.
0.190. What's P? 0.2. You always look here for that second piece, right? Divided by all this mess here. P is 0.2, so what's Q? 0.8. Divided by N, 996.
.800 negative.
I got it.
What'd you get?
Negative .800.
0.800?
Negative.
Okay, cool. Yeah, so I get, well, what do I get? I get negative 0.789?
Yeah.
Yeah. So did we make it, so here's the middle, here's 0. We made it about right here, negative 0.79. So did we reject or what?
We did not reject.
Yeah, we failed to reject. We failed to reject the low. Failed to support the high. Is that cool? Did we make it in the rejection region? No. So we failed to reject. What was our claim? I know. Past time. The claim was the hoe, so that's exactly the wording I want to use. We have not found evidence to reject the claim that the percentage of Americans is 20%. Okay, so I know that was a little bit quick, but we'll do some more next time, obviously. Sweet. See you guys later. Right there, the hoe is the claim, and use these words. Nothing just evidence. Reject the claim. And then you look back up, that the percentage of Americans opposed to it is 20%. Yeah, exactly. And that's the weird thing about it. If we feel it's that, we want to say it. We don't want to see that it's further. We want to say it is that. So it is a little weird. You want it, in order to see that you got to fail to get equal. And I know it's a little weird. Well, that tells you that you want to do this. If it was greater, you wouldn't even do it. If it's less than, is it over enough? That's the key.
Yeah.
And we didn't get it like that. Yeah, you're right though. Like do that, and you're like,
It is less.
but if the claim was greater and we found one that was less, I'm not going to do anything. I'm not going to do the test. I'm already screwed at the beginning. It's got to be bigger. The test just sees if it's bigger enough.
Right. Because it's so close. It's only 1 point.
Yeah, exactly. It's not too far away. Yeah.
Interesting.
Oh, good. Thank you. So let me write that down.
Where's your homework?
Right there. I don't think. Oh, yeah.